Hello, my friends. Here is your Maths Geek from GeeklyEDU. After some videos of functions and derivatives, we are ready for today's topic, partial derivatives. This kind of derivatives can be used to study and solve problems with more than one variable. In physics, biology, chemistry, economics, weather, and a long list of disciplines. In total derivatives, we study the change of one variable with respect of the other. In this case, we study the change of the function with respect of only one variable, remaining the others or the other constant, since the functions depends on several variables. The mathematical definition of partial derivatives of a function z equal to f of x is similar to the total derivatives. When we derivate with respect of the x variable, we are going to calculate the limit of the function in a point by evaluating the function in a plus h, b, minus the function evaluated at the point, divided by h when h approaches to 0, where b remains constant, since it is the position of the y variable. We can do the same to derivate with respect to y, but in this case, the variation is in the y value. This is the representation of the partial derivative of a function in a point a, b. As we did in the total derivative definition, we can represent it for any point of the domain of the function when this is differentiable. If f is a two-variables function, x and y, its partial derivatives with respect of x and y are the limits when h approaches to 0 of the function evaluated in any point x and y with a variation in the variable of the derivative, minus the function evaluated in any point x, y. We can express a partial derivative with a subindex in the function of the variable we are calculating the derivative of, as a fraction using a rounded d, and in the numerator we write the function and in the denominator the variable of the derivative. Any of these expressions are read as the derivative of the function f with respect of x. Let's see how the partial derivative can be represented. As an example, we can visualize the function f of x and y in 3 dimensions. If we derivate with respect of the x variable, the y variable remains constant and the plot only depends on the x variable and can be projected as a parabola. If we derivate the function with respect of y, then the function is representing a straight line that only depends on the variable y. And guess what? These partial derivatives are solved using the basic rules of the derivatives. Knowing this, we can solve together an example. We have to calculate the partial derivatives of the function z. We will start with the partial derivative with respect of x. Using the total derivative addition rule, instead of one partial derivative, we have the addition of two partial derivatives. Remember that the terms with the variable y remains constant, while we derivate with respect of x. Calculating the derivative of both terms using the power rule, we got the result. Another thing to remember is that we can use different notations. You don't have to write them all, but I am going to do it so you don't forget it. Now, we will derivate the function with respect of y, using the addition rule and also the power rule. And finally, simplifying. Now, the notation changes because we derivate with respect of y. And this is how we get the two partial derivatives of the function z. Now, you will see that we can calculate the partial derivatives of a function with more than two variables. In this example, we have to calculate the partial derivative of four variables, x, y, z, and t. The terms with the blue box remains constant when we derivate with respect of x. And this partial derivative can be solved with the power rule. And then multiply by the constant terms. When we derivate with respect of y, we have x and z squared as constants. And we have to use the product rule and also the chain rule, since y, t are a function inside the second function. If you are not familiar with the chain rule, you can watch our video of the chain rule in this your favorite channel. Okay, finally, we simplify terms. For the derivative with respect of z, x, y, and tangent of yt remains constant, and we have to calculate the derivative of z squared by using the power rule. Then, simplifying, we get the final result. To calculate the derivative of the function with respect of t, we observe that only appear in the face of tangent, but now is your turn. Write the answer in the comments below and tell us what rules you used.
We hope you liked this video. Press subscribe, thumbs up, and stay geekly.